Hello and welcome back to the IT Camps. My name is John Weston with Microsoft, and this series of camp events we're doing is around Windows Server 2012. In this module we'll take a look at talking about networking capabilities. Specifically in this section we're going to take a look at SMB 3.0 multi-channel. Our agenda for this section talks about what is SMB 3.0 multi-channel, why do I care about that, and how can I use that in my office. And then we'll dive a little bit deeper and look at it technically of how SMB 3.0 works and how we can use this with some specific network cards on our servers. At the end we'll have another video that takes a look at the demos of how to set this up. So what is SMB 3.0 multi-channel and where is this feature in Windows Server 2012? SMB 3.0 multi-channel is a faster aggregated network bandwidth and fault tolerance capabilities. So you think about your file servers that you've got out there today, or just servers in general. How are they connected to your network? Most servers these days come with at least 4 NICs in them. How can I utilize those network interface cards to take advantage of multiple network cards for fault tolerance if one of them fails, and for throughput? Let's say I have the 4 different network cards connected to different networks, and one of them is much faster than the others. How can I take advantage of that? So this allows us to have increased throughput, network fault tolerance, so if we have a single point of failure on our network, our server still continues to work, and then automatic configuration. So why is this important to me and my data center? Why should I care about SMB 3.0? I really don't want to get into the details of the network, but you need to care because of file throughput. Servers store a lot of information, and the bottleneck for most of them is how quickly they can put that information on the network. So with multiple network cards, just by installing multiple network cards, how can we take advantage of all those network cards to be able to get the throughput that we're looking for in our large-scale servers these days that have multiple network cards built in? The other big advantage is fault tolerance. Things happen, networks fail, routers go down, network cards fail, cables become unplugged, but you still want your server to be able to be accessible by all the applications. So if I have multiple network cards in a server connected to separate physical networks, if one goes down, I want it to be able to automatically recover from that and still be able to have my network resources available. And then last is automatic configuration. With SMB multi-channel, automatically discovers the existence of multiple available network paths and dynamically adds these connections as required. This allows us to be able to reduce your administrative effort on the servers without having to continually update them. So let's look at it a little bit deeper and technical of how SMB 3.0 multi-channel really works. Again, this is a new feature in Windows Server 2012. It's also in Windows Server 8. So the prerequisites to install and configure this: first, we have to have at least 2 computers. They do need to be running Windows Server 2012 or Windows 8. It doesn't work with older versions of our operating systems. At least one of the following network adapters. So either have multiple network cards in your server, or one or more network adapters that support RSS, receive side scaling, network adapters that are available with NIC teaming. We'll talk about what NIC teaming is here in just a few minutes. Or one or more network adapters that support RMA, remote direct memory access. So those you have to have before you can actually go to the install. Sample configurations that do not use SMB multi-channel include non-RSS capable network cards, the old traditional legacy cap adapters, and network cards of different speeds. So our cards have to be the same speed. So whether we're, it depends upon whatever speed we're using, the network cards that we're going to hook together with this have to be of the same speed. There really is no install of this. It's kind of an interesting thing. I'm talking about setting all this up, but this happens by default. Notice here there's no install. The default in Windows Server 2012 and in Windows 8, this is enabled by default. Now you can disable it or re-enable it and actually do some kind of configurations of that, and we'll give you the PowerShell commands to be able to do that here in just a few minutes. So in the single RSS capable network card, it talks about one session without multi-channel or one session with multi-channel. So we can actually have multiple cores here using the same network card with multi-channel capabilities. This is a slight improvement over the traditional network card, but again doesn't prevent us from the single point of failure, but we can get through full put of our 10 gigabit network card. Multiple network cards without multi-channel, there's no automatic failover. You can't use the full bandwidth across all the network cards. But with multi-channel, we have automatic network failover. So if we lose one, allows us to be able to combine our network cards together for better bandwidth capabilities. Now if I have single or multiple RDMA capable network cards, if I have one session, again, we still don't have the automatic failover. If we do have multi-channel, we do have automatic failover capabilities, as well as, again, getting the combined network bandwidth available. This allows us to get much better throughput, as well as the fault tolerance capabilities that we're looking with in our high-end networking. NIC teaming is a new concept that we've got. This allows us to bundle together our network cards for a number of different reasons. Allows us to help control that throughput, and so we can, let's say for example, if I've got 8 network cards in a server, I've got 2 of the 4-port cards, I can create teams of those NICs. Now they don't have to match to the physical 2 separate cards that I've got in the server. I could actually team together for strategic reasons for throughput bundling as well as for fault tolerance with NIC teaming. Okay. Notice automatic failover when I use NIC teaming is faster than not using NIC teaming, and this allows us again to combine the network bandwidth so we can get the best throughput of all of our available networks. I've got a great summarization chart here talking about multi-channel RDMA, NIC teaming, and all the capabilities. Notice as we go down the chart, multiple NICs with RDMA gives us the best throughput capabilities. We do get fault tolerance for SMB network traffic, both on multiple NICs and multiple TICs with NIC teaming. Now in a non-SMB environment, notice there's only 2 scenarios where we get the fault tolerance capabilities, and that's in the multiple NICs, no RSS plus NIC teaming, and in the multiple NICs with the RSS and NIC teaming. So if you summarize that, NIC teaming is required for you to get the fault tolerance in a non-SMB environment. We get lower CPU utilization, putting more of the processing capabilities on the network themselves once we get into an RDMA aware RDMA network cards in our environment. So you can see if you're in a large scale environment using these very high-end servers, you can get your much better throughput by getting things more information on the network based upon what kind of network card you're using and how you configure them. Next, let's talk about SMB connections per the interface. For RSS capable interfaces, we only allowed 4 TCP current connections. RDMA allows us for 2 RDMA connections per user interface that are used. All other standard interfaces only get 1 TCP/IP connection per interface. Even with all these combinations, the maximum is 8 total connections per client per server pair. By default, we do recommend keeping the settings, but it is possible to modify the SMB connections. Now, so again, we don't recommend making these changes, but so the next couple of slides here, I'm going to introduce things that you might want to change, but again, we recommend leaving them standard. Notice the only way to modify these SMB parameters are these PowerShell commands. So to see the current connections that we've got right here, notice the set SMB client configurations commandlet allows us to go in and change the maximum number of connections, look at the number of connections per network interface, and allow us to go in and modify some of the RDMA settings. Again, we don't recommend making any changes to this, but it is possible with PowerShell. As I mentioned earlier, this feature is turned on by default with Windows Server 2012 and with the new Windows 8. To turn this feature off, if you want to, here's the commandlets. Set SMB configuration to false. On the client side, set SMB client configuration to the false setting. To turn it back on, if you need to turn it back on, notice you would just use those same 2 commandlets, passing it the parameter of the $true instead of the $false at the end of the PowerShell command. Here's another set of PowerShell commands that you might find very useful in verifying the way that the SMB channel is set up and what the current usage of that is. So to verify that a network adapter is using SMB multi-channel, you use the get-netadapter or get-netadapter RSS features. And then notice we allow you to, both from the client side and the server side, to verify that you've got a good SMB configuration to use multi-channel. And then finally, to verify connectivity, start a long file copy and then go and run your get SMB connection commandlet, get SMB multi-channel connections, and then you also use the include not selected switch, so you make sure you get to see all the performance that's going over your network cards. Another way to look at performance across your network utilities is to look at your multi-channel events. In the event viewer with Server 2012, you want to take a look at your applications and services log, drill down inside of that log to the Windows SMB client operations, and notice here it tells you to filter between event numbers 30,700 and 30,705. So this will show you all the different events that may be happening around the SMB channel. Also included, you can do the get when event commands on your PowerShell to help you understand the events that are occurring related to your network cards. Remember, you can always download Windows Server 2012 by going to our short URL here, aka.ms/hwws2012. Also, there's a bunch of great free online training about our private cloud scenarios with Microsoft Virtual Academy. To get to Microsoft Virtual Academy, it's aka.ms/virtualacademy. It's all free. It's great training, so go try those online.